just to answer this all. All of it, I think right. I just answered myself.
Okay, today we're going to continue working on PVA problems and also bring in particle motion. So some of these, so I'll be checking these homework problems from yesterday on Monday. Now, 97 through 100, I put those problems in the packet. So I'll do 97 with us, and then that will kind of help you understand, you know, how the problems are set up, and then you can try the other problems. So on Monday, I'll just I'll check these problems, and then you can just turn to the packet and show me 97 to 100, if it makes it easier, since the problems are, I printed them out, makes it easier to do. And also on my website under Thursday, I have these problems worked out. You can always go and look to see, to check your answers that way. Okay, so let's go to page 19. Your package. I'm sorry. We need to finish page 16 first. So page 16. Okay, so we talked about how PVA is just position, velocity, acceleration, and they're just the relationship between those three functions is that they are just derivatives of each other, right? Velocity is derivative of position, and acceleration is a derivative of velocity. And you know, the easy part is the calculus here. So you just go through the derivative to get go through power rule to get to the derivatives, and then the rest of the problems you're just pulling information from these three functions. Okay. So I think we left off on number 11, and so let me pick up where we left off here. So number 11, find the average velocity from 0 to 2 seconds. So here's a definition for average velocity. Average velocity is defined as the change in position divided by the change in time. So because velocity is defined as the rate of change of position, right? The slope of position. So it makes sense that our average velocity is the change in position over change in time. Our p-values are 0 and 2. Position at these time values are h of 2 minus h of 0. So we can use our calculator. Well, I'll just go ahead and find those values for us. So h of 2 is 144. Well, I think we gathered that from before, right? H of 2 is 144. Minus h of 0, which is the ball at the beginning, which is at the top of the building, which is 80 feet. Over 2 minus 0. So over the course of the 2 seconds, the ball is going to drop from 144 to 80 feet. And then if we just do the change in position over change in time, we can figure out the average velocity, which in this case is negative 32. Sorry, positive 32 feet per second. Now, why is this so troublesome for many of us, you think? Yes, that's right. So I think two things. One, we're either using the formula incorrectly, or the other is that this word is so misleading, right? You see the word average velocity, and then your tendency is to be, well, why don't I use velocity function because I'm dealing with velocity? But that's different than instantaneous velocity. So this velocity function is going to tell you the velocity at any moment in time, which is different than what it's asking here. Here it's asking for, you know, what is the change in position from one point to the next. So we're really not dealing with velocity if we're trying to find average velocity, right? Same thing with that example that I gave earlier yesterday, right? If you're on a road trip that takes 300 miles, that spans the course of 300 miles, and then you take 5 hours to get there, you divide those two and you get 60 miles per hour, right? But in finding that average velocity, you did not use velocity at all, right? You did not indicate how fast you were traveling at any moment in time, but you were just taking the total distance and divided by the time, right? So in that sense, right, you would never use velocity information to get average velocity. Same thing here. You're not going to need velocity function to find the average velocity here. And the other thing is thinking of average velocity as something else, right? So I think some students would put things together and say, okay, velocity is v of t. Average means adding two numbers and dividing by 2. So then they would say v sub 0 plus v sub 2 divided by 2, right? That's maybe a way that students would think about average, but that's not how we define average velocity, right? It's not the average of two velocities, it's the change in position over change in time. So just have to kind of get used to it, but just to let you know, on the quiz, this is the one that's most often missed because it's just so easy to look at that velocity and be thrown off with what to do with that. Okay, so just put a star next to it because it is a difficult one, I think, for us to kind of wrap our heads around. Okay, so number 12, find the average acceleration. So in much the same way, how do you think we can define average acceleration?
Change in speed over change in time.
Close. Change in velocity. Yeah, but you get the right idea. Yeah, because we know acceleration is defined as the slope of velocity, right? So therefore, we can say acceleration is defined as the rate of change of velocity. So exactly right. So v of 2 minus v of 1. Here, let me write out the definition first, and then we can do the exact problem. So average acceleration is defined as the change in velocity divided by the change in time. Okay, so v of 2 minus v of 1 divided by 2 minus 1. So the velocity at 2 seconds, I think we gathered that from previous problem with 0. Velocity at 1, I can plug 1 into the velocity function, and I get 32. So clean that up, negative 32 over 1 is negative 32. And what do you think the unit of measure is? Feet per second squared, right? So even though we never touched the acceleration function, we are doing the change in velocity over change in time. So that's going to add another rate to that velocity. So feet per second or feet per second squared. So sometimes I see students, when they see average velocity, they're thinking, okay, I know I'm not supposed to touch velocity, so they end up touching acceleration and they do change of acceleration over change in time. Or, or they would want to involve acceleration when they did average acceleration. So it's a lot of things that can go wrong in terms of misinterpreting. So yeah, so we want to have us kind of look at that and think about it and be able to understand, why is it that it's so often missed, and hopefully take steps to avoid those mistakes. Okay, number 13. Is the speed increasing or decreasing at t equals 1 second? Now, we talked about increasing, decreasing speed a little bit yesterday. So let me go back and review that. Speed is considered increasing when the velocity and acceleration have the same signs. So if velocity and acceleration are both positive, or if they're both negative, then we know the speed of this object is increasing. Okay. The flip side is that speed is decreasing when velocity and acceleration have different signs. So it doesn't matter which one is which, but as long as one is positive and the other is negative, we know that object is slowing down. The speed is decreasing. All right. So let's go back to this one here. Is the speed increasing or decreasing at t equals 1 second? Okay, so we have to gather some information here, right? We have to know what the sign of velocity is at 1 second. So we know velocity at 1 second is 32 feet per second. We also need to gather information about acceleration at 1 second. Acceleration is always negative in this problem. Okay, so what can we conclude about speed?
Decreasing.
It's decreasing because the signs are different. So we say speed is decreasing. At t equals 1 because b of t is greater than 0 and a of t is less than 0. And so we're going to have to learn to use these because statements to justify our answer, and that's the way to do it, to indicate that we understand that we are comparing the signs between velocity and acceleration. All right. I had you guys star number 13 and 14 because the change in a slight change in word is going to impact the way that we interpret the problem. Okay. That slight change, speed versus velocity, makes all the difference here. So if you look at number 14, is the velocity increasing or decreasing at t equals 3 seconds? Virtually sounds like the same thing that we're asking for 13, just a slight change in word. Now, is this talking about velocity? What's it talking about? The key words are here. I want to underline it and have you guys think about it. Is the velocity increasing or decreasing? So when we talk about an increase or decrease of velocity, what are we talking about?
Acceleration.
Talking about acceleration. So this is saying, this is talking about the rate of change of velocity, which is really acceleration. So the way that we could rephrase this to make it easier to understand is to say, is the acceleration positive or negative? Right, and that becomes a very easy problem because we just look at acceleration at 3 seconds. Acceleration is negative. So because acceleration is negative, we can therefore conclude that velocity is decreasing at t equals 3 seconds. Now, can you imagine, why it's easy to misinterpret number 14? Because first off, it looks so similar to 13 that if you see this problem for number 14 on the quiz, you may interpret it as number 13, and you would start comparing between velocity and acceleration, right? So that's a possibility. The other possibility is you're looking at that, and maybe you can interpret that as saying, is velocity increasing or decreasing? Isn't that the same thing as saying, is velocity positive or negative? But it's not, right? That increase, decrease changes everything. So this is also the way that AP exam kind of likes to ask their questions. And, they, instead of saying something straightforward, like it's acceleration positive or negative, they're going to include that increase, decrease to see if students understand that, oh, this is not talking about this quantity, it's talking about the rate of change of that quantity, which is the derivative, which is acceleration, right? So, yeah, they like to see if students understand that process of rate of change and that it's talking about something else. So, yeah, you can, 11 through 14, those are very commonly missed problems, with good reason, right? Because the way that things are worded can throw students off if you're not thinking about what it's asking. Good. Any questions here? All right, so we'll definitely get to do some more practice of these problems leading up to the quiz next week, but I wanted to kind of bring that to your attention that these are troublesome problems for students that students miss. So, you know, circle it and think about it, and we'll definitely revisit this. Okay, so let's go to next page here. Okay, so let's tackle some of the problems I assigned for homework. So I want to look at page 19. So in your homework assignments, it has 97 to 100. So what I did was I just took those problems from your textbook and I just copy and pasted it to make it easier to kind of work through since everything is on the same page. So I'm going to work through 97 with you, and then 98 to 100 will just be part of your homework assignments. But you can do it on this page and you can show me on Monday. Okay, but let's talk about 97 so you can kind of see how the problems are set up. Okay, so it says in exercises 97 and 98, use the position function S sub t equals negative 16t squared plus v sub 0t plus s sub 0 for free falling objects. Okay, so let me talk about how we can build off of this function. Okay, so S sub t is a position function, but there are some missing elements that we have to fill in. So first is this v sub 0. So v sub 0 means the initial velocity. So sometimes the problem will explicitly tell you what the initial velocity is. Other times we kind of have to read the problem and try to figure out. S sub 0, anybody have any idea what this means? What this stands for? Yeah, initial position, initial height. Yeah. Okay, so where is this object starting at the beginning of the problem? Okay. All right, so let's read the problem here. A silver dollar is dropped from the top of the building that is 1,362 feet tall. Okay, so the dollar is being dropped. So what's the initial velocity? Zero, right? So it's not being thrown down; it's dropped. So that moment that you let go of the coin, it's not moving for that brief second. So we consider that v sub 0 as 0. So I'll put that up here. V sub 0 is 0. And then what's the initial height?
Oh, 1362.
Yeah, 1362. Okay, so now that will bring us to the specific problem that we're solving, or the specific height function that we're working with. Now that 0t is just going to wipe out that middle term, so we can just drop it and have two terms for our position function. Okay, so part A says determine the position function, which we did, and the velocity function. So we can go ahead and find the velocity function. So go through power rule, derivative process. So